Okay, good morning to you all. Welcome to this session of logic design, switching circuits, digital circuits to the other department, computer engineering. And today we continue with Boolean algebra. The last time we met, we discussed the Boolean algebra, where we introduced and gave definitions, and we discussed approach, analyzing problem, then designing. We discussed the why Boolean algebra part, and the answer to that was to reduce the size of our circuits, probably reducing power and increasing the performance of the system. Why do we need to simplify circuits? All right, why we use Boolean algebra is to simplify circuits. Simplifying circuits means smaller sizes, more or less power, less power to run the circuits. Then we have performance. I think that's the Y part. Now we went through a number of laws: commutative, absorption, associative, distributive. The most important one, De Morgan's theorem. And I think I made the point, you need to understand those laws. If you cannot claim them, you need to understand them. And I think it's useless to claim them if you don't understand where to apply them. And with practice comes that understanding part. Right, today we continue on that. Probably give a few examples on where we can apply those laws, solve problems using those laws. If you can meet yourselves. Or I will look for you, I will find you, and I will remove you. TK. Voila. Right. Right. We also introduced digital logical gates. We also introduced logic gates, the ands, the ors, the not, and we introduced how to use truth tables. Truth tables. We have expressions. We have the logic diagrams, representation of functions. It can either be in truth tables, expressions, or the diagram itself. I think we went through this. All these laws are allowed to reduce sizes of circuits. Why we did all these laws? They will allow us to reduce the size of the circuits. Right, you can forgive me, I'm still to settle in. But as soon as I do, then we'll be good to go. Right. Today we will start with what we call universal gates. Universal gates. Or if you can allow me, let us do an example. I think that will work fine. What is showing on my screen? I need to know what is showing on my screen.
Blank page.
Blank white screen.
Blank page. All right, let's start with what we did last time. We did Boolean algebra, simplifying circuits, simplifying circuits. I want to do an example today. Let's say you have a function. You have a function a b plus z a naught x plus, let's say a naught x plus or a naught. You are given a function f with that expression. This is an expression. A function can be represented by an expression, a truth table, and a logic diagram. You need to learn how to represent functions using these three. So this is an expression. Function f, expression, this one. We want to simplify that expression. If I can count, how many gates do we have here? We have one, this gate. Notice we have this plus, we have this end, we have this plus, we have this end. 1, 2, 3, 4, 5. I can count like 5 gates, probably more. How do we reduce the number of those gates? You can simplify the circuit. I'm not reminding people to mute themselves, ladies and gentlemen. I am removing. So be very careful when you have your mics on. Be very careful with that. I'm not reminding, I am removing. All right. So we have an example there. How do we deal with that circuit? How do we simplify it? You can use Boolean algebra, Boolean laws to simplify that circuit. Okay, let me not be repetitive. Where there goes Thelma. We'll meet on the next lecture. Right. How do we go around simplifying this? To those who have an idea where to start, this is your chance. Just comment to have we have an idea where to start. How do we simplify this? It's possible we can simplify this to just an expression with one variable, a. This can be simplified to f is equals to a. It's possible, we never know. But how do we do it? Where do we start? Anyone with an idea? Using the laws we already have. We have the associative, the distributive. Do you see any distribution in the absorption? Nope. Okay. Let me help. All right. The best way to know where to start. The best way to, we have a chart. Zinyoka Samanyora Azoneki. Yeah. You have to do with my handwriting. A bracket B plus Z bracket X plus A bar bracket. All right. Where we can start? I was saying knowing where to start comes with practice. That's how I know where to start personally. We learn different. Most of you will probably be more efficient in how we learn and approach answering some of these questions. But personally, it's practice. The more variables, the more expressions you deal with, the more you understand how to approach. So for this one, I know I can start with De Morgan's. I can start with De Morgan's theorem with this one. What does De Morgan say? Definition. What does De Morgan say? De Morgan says if you have two functions, two variables, a plus b not, it is the same as a and b bar. That is De Morgan. Or the other one goes like a and b not is equal to a naught or b naught. I advise you to get used to using ors and ands instead of plus and times, where me myself, I'm not even used to it. But it just feels right when you say a and b naught. For this one, a and b naught is equals to a naught or b naught. This is De Morgan. We can start here. So if this is our starting point, we can apply this on the expression f we have. We can apply that on the expression f we have. All right. We can do this. And two bars. There's a law which says a is the same as a naught naught. There is a law which says that. I probably didn't give you, but I'm giving you now. There's a law which says that if you have two n's, it's the same as both of them canceling out each other. So our f, the function f, we can start there. It's the same as that same function with two bars on top of it, two knots. Right? After we're done with that, we can then simplify using De Morgan. We can then simplify this using De Morgan. So where do we go from there? Where do we go from there? We have an expression where we have, if we apply De Morgan between the expression, the first variable a and the rest. All right. If we say this is the same as a, we apply this row. We separate a and the rest. This is multiplication, no? This is a and the rest. So if we apply De Morgan's there, between a and the rest, we have the first bar, a bar plus a bar plus b plus z x plus a bar. This again with a bar. True or false? You're having some difficulties putting this out as clear as I would have liked, but do you get the idea of what I just did there? Feedback. I can repeat if necessary.
Yes, sir.
Yes,
Right.
sir.
We applied this row and we separated A and the rest. Right. We can further this by applying De Morgan on this part. This means we can have something like this. Our first bar, then we have A bar plus B plus Z. If we apply De Morgan, it's now, let me do this, Z bar plus X plus A bar. Where is our other bar here? Is it like this? Is that correct? Get me some feedback. Is that correct? Yes or no?
Apa sikudiwa rimwe bayire pana x plus a x or a.
X or A, not another bar. X plus not should have another bar. Like this. Is that correct? Nope. Any feedback? I need the feedback. Whilst I try to find out. Nish. What is visible on my screen at the moment? Hello.
Zvatiri ndizviri visible zvamanyora zvo.
Okay. All right. This is the same as A bar plus B plus Z X plus A bar. This like this. Can we do this? Can we remove this and put an end and put something like this? Is this possible? With another bar on top. Is this possible? Applying the Morgans. Not yet clicked. Okay. I'll just continue. Not yet clicked. There's someone in the chat. It's possible. Thank you very much. All right. So we continue from there. If we apply the Morgans on this part now, if we apply the Morgan on that part now, we now have A bar plus B bar multiplied by end bracket Z bar plus X A bar. Is this possible? I think so. If we apply the Morgans to, let me try separating this. Problem is, I understand what I'm doing, but the question is, are you understanding the way I'm putting it out? That's why I'm having difficulties. All right. So what we are doing here, we are applying these laws, these two laws. A plus B, A, B, not. All right. So if I apply these two laws here, this term, Z, X plus A bar, this term here, what I have, A is equals to Z, not bar, then B is equals to X or A naught. So if I apply this A and B to this one here, nope, this one here. What do I get? Just a minute. Okay, what do I get? I come here. I now have A bar plus B bar, which is Z bar plus X plus A bar bar. We come here. I then simplify again. I then simplify again. Which part can I simplify here? Let me see. I then simplify again. The plus part. Where's my whiteboard? Just a minute. Right. I can then simplify this one. I think there's another bar here. I can then simplify this part here. So that I have A bar plus B bar bracket Z bar plus another bracket. This, if I apply A plus B bar is equal to A bar B bar. So we now have X bar multiplied by and A bar bar. If I apply them again on this one here, I hope I'm not complicating this. It sounds easy in my head, believe me. But approach when teaching it. Right. True or false, where we are here. If I get an a yes from anyone, then I can continue. Right. I'm waiting.
Yes.
Thank you very much. Right. Then if I can apply the formula A is equal to A 2 bars. This is the same as A. I can simplify. This one is the same as A here. All right. This here is the same as A. Correct?
Yes.
All
right.
But say,
yes.
Affect ni this top bagay.
Yeah, but we are just simplifying from the top bar will affect everything, but it doesn't affect.
So
yes.
What if we use this one so that we
remove the bar.
Yeah, we remove this bar. We know that it will become A plus B, then times Z. Then we know that this A will have a naught.
No, it's not possible.
It's not.
Yeah, it's not possible. Right.
Okay.
I think this is the most we can simplify this. This is A bar plus B bar Z bar plus X A. On top of that, this bar. I'm not sure how many gates did we remove here. Where did we start? We have 1, 2, 3, 4, 5, 6, 7, 8. I'm not sure if we simplified this one as per se, but I think it's more of showing application of the law. Where are we in Africa? The law, we have De Morgan's. Right, this question, I thought it could be simplified. We simplified, but not to an extent we would have liked. At least it showed how we can use De Morgan's law how we can use De Morgan's law. Let me try to find out. Let me try to find a better example. All right. This one clear. Let me do this. Right. We have A bar B, A plus B plus A. I should have find out solutions on this before starting, but unfortunately I did not. Right. We want to use Boolean algebra to simplify that expression. The first one I gave, where I just took it from the internet, and I thought it could be simplified, but nope. It only showed us how to apply Boolean algebra. We have another one there. Hopefully, we can simplify it to see if this can be reduced maybe to one or just two variables instead of the many gates we have there, one or two gates instead of the many gates we have there. Knowing where to apply each of the laws, comes with practice. So after this, if you can get as many examples as you can get from the internet worked, probably it will help you, and also I think help everybody. All right. Application. We can start with De Morgan. How do we apply De Morgan's here? What can we separate? We can separate starting with this one. This bar on top here. Let's take this one and we deal with it. We leave this one as it is. We have bar A plus B, something like this, right? This here is in bracket. Running out of time, and we didn't even do that much. Right. If I apply De Morgan, which says A plus B bar is equals to A bar B bar to this one, what do we get? Anyone who is getting where we are coming from and going, what do we get? If I apply this formula here, yes?
I think we get A bar plus
A bar
plus bar bar, under that B plus A.
A bar plus bar bar
B plus A.
B plus A.
A.
How true is this? Nope. I'm applying A plus B. I get A product B. Where is your product here?
Aren't we expanding that second one that you highlighted using De Morgan?
I highlighted this whole thing. A plus B plus A.
Okay, we get A times A and bar bar B plus A.
All right, so we get A bar plus B times. Thank you very much. Times
B plus A bar bar.
B plus A bar bar. We can simplify B plus A bar bar. What do we get? B plus A bar bar. What do we get?
We get B plus A.
B plus A. Thank you very much. So here we have, this is the same as A bar, not B plus A, right? We can simplify this. This is A bar, B plus A bar, A, correct? Is that correct?
Yes, it's correct.
Expansion. Yes. All right, there's a rule, A bar, A. What's this equal to? A bar A. If you have A, 0, 1, A bar
A.
Is it A? Is it A? There's a chart there. I don't think it's A. It's 0. Thank you very much, Tawana. A bar is 1 here, it's 0. What is A bar? It is 0 here, it is 0 here. So this is equal to 0. So from this whole expression, we set aside, we only have A bar B. Now we are simplifying. I think that one is a perfect example of how we can use the laws to simplify. We started here with this whole expression. It's the same as A. Oh, yeah. It's the same as A bar B. So if we can simplify, we can say A bar B. So this is the same as A bar plus B, the first term, and A naught B, correct? Work with me so that if I go wrong, it also means you went wrong with me. I don't have the answers for this one. Is that correct?
Yes, it's correct.
Yes. Now, we can also expand. We can expand this. So if we expand, this goes into the bracket, we get A bar B, A bar, plus A bar B with another B, correct?
Correct.
All right. What is, we can remove A here. Let me see, we can remove A bar, not remove, but make it subject of the function. I'm not sure if it's correct language. A bar, here we have B plus B, B. Can we simplify this? Nope. Practice, that's where the practice comes. This can be simplified. But I'm trying to find a way how we can simplify this. If I put a B, we have A bar plus A bar B. This can be simplified. What is A bar?
A.
It's A bar, no? A bar. What is A bar? A bar. Can we simplify it? Yes, it's A bar. Thank you. So it's B A bar plus A bar B. Did you simplify anything here? I don't think so. Another way of simplifying. Think, ladies and gentlemen, that thing can be simplified. But how you simplify it comes with playing with the numbers. We only have, how do I know it can be simplified? We only have two variables, A and B. But here we have three of them on the same expression. So it means it can be simplified. That's how I know it can be simplified. But the how part, playing with the numbers.
So what if we start by simplifying A bar on our first expression there and simplifying BB so that we'll be left with A bar plus A bar.
There we have our answer. Who is this? Who is
Tanaka.
This? Tanaka, thank you very much. Whatever it is that is happening today, Tanaka to the rescue. All right, we have A bar multiplied by B, this first term, plus A bar B, this second term. We have already articulated that this is the same as A bar. This is the same as B. Voila. Did we simplify anything there? Yes, I think so. Is this correct, Tanaka?
Yes, it's correct.
Thank you very much. Now, can you further simplify this? What is A plus A? What is A plus A? What is A plus A? A plus A is equals to A. Tawanda. Thank you very much. So it means A bar, B bar, B plus A bar, B. These are same terms, right? This one and this one. So this is the same as A bar B. We can lose this one. Voila, we have simplified. We have simplified from this one to this one. Chat A. Right, that's an example of how you can simplify a function. As you can see, it comes with practice, knowing where to apply the rules. You have a number of rules there. How to apply them, it comes to practice. Now, I have less than 1 minute. You know the procedure. I'm going to end the session. Then we continue with what I had prepared for today. Note that example. Okay, we log in soon after, just 1 minute. I'm not recording this one. So we log in soon after.